this is the guts of an old circa 1996 um, American Power Conversion uninterruptible power supply network power cell. That's what's written on the front above the switch. This is the main logic board for it. It's aside from loads of passives, there are a bunch of chips on here, mostly either 4000 series CMOS or improved TTL variants like this, which is a 74C14 hex Schmidt trigger NOT gate, and I think there's another one. Yeah, there's another one down there. Pretty much most of the chips down there, like an HEF 4001, 4011. That can't read, kind of hard. That's 4000 something, kind of hard to read, but anyways, pretty much all various logic chips. There's this LM339 quad comparator. That device down there is a Linfinity SG3524 PWM chip, which is what actually drives the inverter portion of this, which I'll get to in a bit. And then down there, there's an MF4CN fourth order Butterworth low pass filter. Butterworth being a type of filter characteristic. Then elsewhere on the board, there's this small transformer, which is what actually runs all the control circuitry and charges the batteries when mains is available. Because I've heard people say that in other videos of these things that the inverter portion of it runs continuously, but that's not the case, because as you can see from the heatsink design, we're just big bits of formed, looks to be 3/16" aluminum or some similar metal, are designed to run for only a couple of minutes at a time, because these are really only designed to run for a few minutes while the load they're being connected to is being shut down. As you can tell from the heatsink design, these aren't designed for continuous operation, which is one problem associated with converting one of these into use as a regular inverter. Also, ones like this that don't have a test feature, they can't be tricked into black starting. So if you try and start one of these up when mains isn't available, it'll just beep at you, or it would if the beeper hadn't been disconnected on this one. Can't remember if I did that, because I did have to replace the batteries in this sometime late 2005, early 2006. That's also why I've got this thing open anyway, because the batteries have been crapped out, and well, if you've seen dead valve-regulated lead-acid batteries, are all bulged and crappy, and yeah. And anyway, so then this is the transformer for the inverter portion of it. It is a fairly typical front-end transformer type inverter design, where you've just got these two purple leads, which are part of the primaries in this case. So that would be the equivalent of having one of these as a center tap transformer, where those would be just a single wire, because some are like that. This just happens to have two separate primary windings, but center tap would also work. And then each of these two primary winding leads connected to one of these two sets of MOSFETs. There are four T220 package MOSFETs connected to each heatsink, and what happens is that the SG3524 alternate through various control circuitry and some MOSFET drivers, because there's some T220 devices around these which are serving to help drive the MOSFETs. They alternately turn each of these groups of MOSFETs on, and it's a fairly similar process to what happens in inverters like these, except these, the transformer operates at about tens of thousands of cycles per second, not 120 cycles per second, or thereabouts. Then there's some QRM inductor, or inductors for QRM suppression. There's a little metal oxide varistor right there. For surge suppression, there's a little 1 ampere PCB mount fuse right there, and another one right there next to this transistor. And then down below this transformer is the relay that actually transfers the load receptacles from mains to the transformer if the electricity quits. And other than that, there isn't a whole lot to see in this. Just a fairly typical late 1990s UPS, very much.